Bismillahirrahmanirrahim, starting the third session of lecture number 7 and continuing with the examples of triple integral. So today I will do few more examples in this session and then give you few examples to you for just for practice. So starting with the new examples. So the first example is evaluate the integral, third integral over surface S having dx, dy, dz, where the function is x, y, z, and then we have dx, dy, dz, where S is a sphere, where S is the sphere given as x square plus y square plus z square equal to 1, and all x, y, z are positive, and all of x, y, z are positive. So this is the statement given to us. It simply means that we need two limits for each and every variable. So I can easily take the values of x, y and z. Since x, y, z are all positive and lying in the positive means they are lying in the first quadrant, because in first quadrant we have all positive values and the first quadrant starts from 0. So it means when he says that x, y, z are all positive, it simply means that given is that x is 0, y is 0 and z is 0 is given to you. So it means the lower limit is given to be in all three variables. So if I decided to try with z first, then it means I have one value of z equal to 0 and the other value is z square is equal to 1 minus x square minus y square. It means z is equal to under root 1 minus x square minus y square. Since I have two values minus and plus, I can use minus and plus both. So since I have the option, so it is better to just use the positive value. So I am treating that z is equal to 0 is the one limit and z is equal to 1 minus x square minus y square is the second limit. So now I am integrating with respect to z first and then we will try y and x accordingly. So now it means there are double integral, and on integrating, leaving x, y outside, integrating z means z square by 2 and limits are 0 to under root 1 minus x square minus y square and dy and dx. So now we have only z square by 2. So this 2 I can easily write outside the integral and then xy. And now substituting the upper limit means z square means 1 minus x square minus y square and lower limit is 0. So this is dy and dx. Now I can multiply this y and x with this one. So 1 upon 2 integral. Now I have xy minus x cube y and minus xy cube, dy and dx. Now it is time to analyze that what will be the limits of y. Since we have finished with z, so it means now the lower limit of y is 0, and since no z is there, so now I have x square plus y square equal to 1. So z is now eliminated, z is becomes 0 because we have consumed the z. So it means now we have x square plus y square equal to 1, just a circle to represent. So y square is equal to 1 minus x square, so y is equal to under root 1 minus x square. So it means I have limits 0 and under root 1 minus x square. So it means now I have 1 by 2 integral, and then I have x into y square by 2 minus x cube into y square by 2, and then minus x y 4 by 4, and this is dx, and limits are 0 to under root 1 minus x square. Taking 1 upon 2 common outside, so it means now we have 1 by 4 outside, then integral, then I have x into y square minus x cube into y square minus x into y power 4 by 2, and limits are 0 to under root 1 minus x square, and then dx. So 1 by 4 integral, substituting the above limit, so x into, that is y square means 1 minus x square, minus x cube, y minus means 1 minus x square, and then we have minus x by 2, y power 4 means 1 minus x square square. Lower limit is 0, so all values will be 0. This is dx. So now I have 1 by 4 integral. What is I have? I have x minus x cube minus x cube minus minus plus x power 5 minus x by 2. It means 1 minus 2x square plus x power 4. I open the square, and this is dx. So if I take 2 common outside, it will be 1 by 8, then integral, this 2 will be multiplied by 2x minus 2x square minus 2x cube minus 2x cube minus 4x cube, because the same, this is 2x power 5, and then minus x minus minus plus 2x cube minus minus plus 2x cube and minus x power 5 dx. So it means on simplified form we have 1 upon 8 integral, then we have what, 2x minus x is x, minus 4x cube, 2x cube is 2x cube, 2x power 5, x power 5 is plus x power 5 dx. And now what will be the limits of x? Now y is also 0, so it means lower limit of x is 0, and upper limit is x square equal to 1, so x equal to plus minus 1, so 0 to 1. So upper limit is 1, so now we simply have 0 to 1, so it means I can write 1 by 8, then x square by 2 minus x power 4 by 4, so it is 2, and plus x power 6 by 6, and 0 to 1. So it means I can simply write the upper limit minus lower limit means 1 upon 8, upper limit is 1 upon 2 minus 1 upon 2 plus 1 upon 6, and lower limit is 0, so all values will be 0. This cancel with this, so this is equal to 1 upon 48. So 1 upon 48 will be the answer of this thing. So this is today's example number 1. So let's take another example in the similar context. What we need is just the practice of these triple order integration. I am leaving this so you have another look on this. Meanwhile, I am writing another example to evaluate the triple integral, and we have the function under root x square plus y square, then we have dx, dy, dz, and then we have where S is the solid bounded by, where S is the solid bounded by the surfaces What are the surfaces? The surfaces are x square plus y square equal to z square and z is equal to 1. These are the surfaces which are given to us. So let's try with respect to z first. So what are the limits? The limits are z equal to 1 and z square equal to x square plus y square. So it means z is equal to under root x square plus y square, and again this is plus minus x square plus y square. So taking the positive direction, so what is needed? We need to integrate x square plus y square with respect to z first, and then we will try dy and dx. And what will be the limits? Limits must be under root x square plus y square here and 1 here. We can write the vice versa as well. It doesn't matter that this is from 1 to under root x square plus y square. So if on integration I will get under root x square plus y square as constant and then z, and it is under root x square plus y square to 1 dy and dx. So when I will substitute the values, so it will become under root x square plus y square. The upper limit is 1 minus lower limit is under root x square plus y square dy dx. So it means I finally have under root x square plus y square minus x square plus y square dy dx. Now I am telling you the limits of y and x, and then you will solve yourself the further question. What will be the limits of y? We have now the limits of z and the limit of 1. Since z is equal to 1, if I substitute it as z equal to 1, so I will find that x square plus y square equal to 1. So y square is equal to 1 minus x square. So y is equal to plus minus under root 1 minus x square. Since I do not have any other value of y, so I will use these two limits. That is minus under root 1 minus x square and plus under root 1 minus x square. We use these two limits, and once we will solve this one, then what will be the requirement? Then y will be treated as 0, so x square equal to 1, so x will be plus minus 1. So the final limits of x will be minus 1 and plus 1. So what is required? I am just telling you this is minus 1 to 1, and then under root 1 minus x square minus and under root 1 minus x square plus. What will be the outcome of this one? Under root x square plus y square, under root x square plus y square minus x square minus y square dy dx. So with respect to y, you can use the formula. I am highlighting the formula here. So you can easily write down the formula just in order to use the correct integration. So the formula will be, and if we have this kind of integral having under root, I am writing as y square plus x square dy. So treating x as a constant, so outcome will be y by 2. Then under root y square plus x square plus y by a sine hyperbolic inverse y over a. So this will be the formula. This is this will be x square by 2. X square by 2 sine hyperbolic inverse y over a, y by 2, treating x as a constant. So we can use this formula here, and then integral of minus x square will be x square y, and integral of y square will be y cube by 3. So then you have to solve yourself the remaining question. I tell you the formula. So just applying this formula here, and then this will be the straightforward integration. So before ending this third order integral, I am writing here few examples for you. So you have some kind of questions to apply all these things what you have learned in this triple order integration. So now some practice problem for you, and inshallah from onward, from the next lecture we will start a new topic. These are the practice problems on third order on triple integration. So number 1 is minus 1 to 1, minus 2 to 2, minus 3 to 3, and we have only dx, dy, dz, dx, dy, dz. All three are constants, and if you will do it correctly, the answer will be 48. Then in number 2, we have 0 to 1, 0 to 2, 0 to 1, 0 to 2, and then we have 1 to 2, 1 to 2, x square y z dx, dy, dz. The function is x square y z, we have dx, dy and dz, and the answer is, according to me, will be 1. Then in number 3, 1 to 2, then we have 0 to 1 and minus 1 to 1. Then we have a function x square plus y square plus z square and dx, dy, dz. And then we have the answer as 6. Then number 4, 0 to a, 0 to x and 0 to x plus y. The function is e to the power x plus y plus z, dz, dy, dx, dz, dy, dx. This is the correct order. Why I told you that if we have two limits x and y in any integral, it suggests you, it gives you an indication that you have to integrate with respect to z first. So taking another example, number 5, triple integral, and then we have only x minus y plus z, and then we have dx, dy, dz, dx, dy, dz. The limits are given in this way, that x is between 1 to 2, y is between 2 to 3, and z is between 1 to 3. Then we have another example. Then we have another example. Maybe I didn't write the answer. Answer will be 2. 1, 2, 3, 4, 5, 6. In 6 we have 0 to 1, 0 to 1 minus x, 0 to 1, 0 to 1 minus x, and then we have 0 to 1 minus x square minus y square. It simply means we have to apply dz, dy and dx. Z first, then y, and then z, and answer must be comes out as 1 by 3. Then in another example, 0 to 1, sorry, 1 to e, 1 to e, 1 to log y, and then we have 1 to e power x, 1 to e power x log z dz, then we have dx and then dy. So answer must be half e square minus 8e plus 13. Then in example number 8, we have 0 to 1, what will be the example number 8? Yes, 0 to 1, 0 to under root 1 minus x square, and 0 to under root 1 minus x square minus y square. The function is x, y, z, and we have dz, dy and dx. And then final answer will be 1 by 48. So maybe I done this example before, maybe. Okay, these are the examples you have to solve. Maybe I have solved myself one or two. I have doubt in this example that I think I solved it just a little earlier. But okay, these are the examples, and these examples will provide you enough practice. I give you the answers as well, and if you need it, then inshallah we will discuss all the aspects of limits in our live session as well, which will be done just after your midterm. So a goodbye from now, and we will start the lecture 8 with a new topic inshallah. So it's goodbye now.